Hey guys, welcome back to this course. In this particular topic, let's take a look at the surface tab, and in the previous topic we were taking a look at the curve tab. Now the next tab is this particular tab, which contains 4 panels and 81 components. So we'll be taking a look at some of the most important ones over here. So you can find this particular file named as the surface tab, which is the 5th tab that we are looking at right now. You can find this under your exercise file components, your exercise file downloads. So let's start with the deconstruct BDEP component over here. So I have created a box inside Rhino and imported it inside Grasshopper using the BDEP component like this, and I have used the deconstruct BDEP component. You can find where it is located. You can see it's this particular component under surface, and it's there under analysis. So what this does is it breaks up a geometry into faces, edges and vertices, which is basically the surfaces, the lines or the curves, and the edge points. So if I turn this off and if I turn this off, and if I just keep this on, which is the faces, these are the faces that I have gotten after breaking it up. These are the lines that I have received after breaking it up, and this is the group of points that I have received, or the vertices that I have received after breaking it up. So you have surfaces, curves and points. So now let's take a look at the next component, which is dimensions. You basically input a surface like this, can be of any shape, and you basically get the u and the v dimension, which is basically the x or the y dimension of that particular surface. In this case it's 39.18 by 41.71, which I have shown through the panel components. Let's take a look at the next component, which is area. So area you can find right here under the surface tab. Under analysis you can find area. It's got a sign of meter square. It takes in a geometry. In this case I've given it the same surface, and you can basically calculate its area and its centroid. So this is the oddly shaped surface. It will give you the centroid of this surface, which is the central point, and it will give you the area of this particular surface, which is 1086.35 in this case. So I'll turn this off. So let's move on to the next component, which is volume. The volume of a component is pretty much the same as the area, except for it's in 3D. It takes in a BDEP. In this case I have given it a box, and it basically calculates the volume, which I have displayed through a panel, and it also calculates the centroid of this particular BDEP like this. As you can see, it's located right in the center. I'll just set this view like this over here so that I can pan around properly, and there you go. Have the centroid right in the center of this particular box, which is this particular point. So I'll turn it off for now. Next component is evaluate surface component. This component basically takes a surface, in this case this particular surface, and what you can do is you can evaluate this surface by creating a point on the surface, and you can basically receive data about that point, which means you can receive the location of the point, the normal direction from that point on the surface, the u direction and the v direction of that point, and the frame of that point. These are the outputs. These are the outputs of this particular component. So it takes in a surface, and you have to reparameterize it. This is the sign of reparameterize. So you basically have to right click on surface, click on reparameterize. That's because when we create something in Rhino, the units and the coordinates of all of these points, of the lines, is not known to Grasshopper. So we always have to tell Grasshopper that please reparameterize my geometry and always change it from 0 to 1. So whatever these particular coordinates might be, 13, 15, 60, minus 100, minus 1 to 0.31, it doesn't really matter. It basically takes all of those numbers and reparameterizes it to 0 to 1. So that's what it has done. And after fixing in surface, you have to fix in this particular thing, which is basically MD slider, which is a multi-dimensional slider. Till now we have been using a single dimensional slider, which is the number slider. So if you just double click and type number slider, you get this particular thing, which is numeric slider for single values. You can only change the value in one particular axis or one particular direction. If you want to change it in two directions simultaneously, then you have to double click and type MD slider, which is a multi-dimensional slider. It will initially look like this. You can decrease its size, and you can basically see that the starting point is 0, ending point is 1. So it basically gives you two values, x and y, and you can use this and fix it inside point, which will create, or which will actually generate the coordinates of that point, which in this case is 0.13, 0.83. If I turn this on, you can actually see this is the point right here, and I can move the point as if this thing is actually my surface, and I'm moving around the point accordingly. And if I change this thing, and if I basically delete the reparameterization selection, if I right click and deselect the reparameterize, now you can see what actually happens. The point does not move throughout my surface. So you always have to right click and reparameterize in these kinds of components if it asks for. So I'll turn all of these things off. Now let's move on to 4-point surface. 4-point surface is a pretty simple component. You can see it is included in the freeform section under surface. It takes in 4 points and creates a surface out of it. So I have created 4 of these points like this, and it creates a surface out of the 4 points. So I'll just turn this off. Next component is the boundary surface. It takes in a curve like this, and it will give you a surface out of that curve. It's pretty much like the planar SRF command in Rhino. I'll turn this off. Next component is the edge surface. Edge surface is located right here under freeform, and you have 4 curves that you can input, and it will create a surface out of those edges. So I've input these 4 curves separately, and it will create a surface out of the 4 curves. So I'll turn this off for now. The next component is loft. So what loft does is, it's pretty much like the loft that you have in Rhino. If I turn these 3 curves on, you see I've created 3 of these curves like this. So the bottom and the top are of the same size. The middle curve is a little bit scaled down. So if you input 3 of the curves, and you also have to make sure that they are inputted in a particular order, which means they have to be the first, second and third. You can't input this first and then this and then this, otherwise it will create a huge error in Grasshopper and this component will turn red. So you have to input it in order. So this curve has been inputted first, this one has been inputted in the second place, and this in the third place. So this is what it will give you. It will basically loft between these 3 curves and create a geometry like this. So I'll turn this off. Now let's take a look at the next component, which is cap holes. So if I turn this on again, you can see that the top part and the bottom part, they are not capped or they are not closed. If you want to close these, this kind of a form or this kind of a shape, you can use the cap holes component, which is located right here. It basically caps or closes the empty surfaces or the empty B-reps. So if I turn this on, you can see it basically has closed my B-rep from the top and from the bottom. So I'll turn this off for now. And you also have the ruled surface. The ruled surface is a pretty simple component. What it does is it takes in 2 curves like this. Just turn it on, takes in 2 curves like this, and it creates a surface between these 2 curves. You don't need a third or a fourth curve, so it creates a surface like this between the 2 curves. You'll find the ruled surface component right here under freeform in surfaces tab. Now let's take a look at the next component, which is extrude. Extrude is basically the extrude command in Rhino. You can extrude in Grasshopper. You just have to give it at the base. The base is basically the surface or the geometry that you want to extrude or the face that you want to extrude, and you also have to give it a direction of extrusion, which in this case is the z-axis or the z direction. And you also have to attach a number slider to it because you want to be able to control the amount of extrusion that you want. So if you extrude this particular surface right here, it will give you a 3D block like this. The amount of which you can control using this number slider like this. You have to input the direction and the number slider goes in the factor. So I'll turn all of this off and let's move on to the next component, which is pipe. Pipe component basically turns a curve like this into a 3D pipe. So it basically creates a pipe out of curves like this. So I have a random free flowing curve and you just have to give it the curve, the radius of the pipe and the cap, which means do you want to close it from both the ends, do you want to close it in a flat shape, or do you want to close it in a round shape. So you can see over here, if I turn this on, it has basically created a pipe out of this line, and I have selected this the second option, which is close the ends in a curvilinear fashion like this. If I change it to 1, it closes the ends in a flat fashion like this. If you change it to 0, it does not close the end at all. And if you have these kinds of errors in your model, just change this to high quality and it will be much better. So you can change it to 1, which will close it in a flat cap, and you can change it to 2, which will close it in a round cap. You can move your mouse cursor on this caps input and see that specifies the type of caps. 0 means none, 1 means flat, and 2 means round. So you can basically create a number slider according to that and create a pipe. And this basically changes the radius of the pipe like this. So I'll turn this off. Now let's take a look at the sweep component. You also have the sweep command in Rhino 6. What the sweep command does is it takes a section and it takes a rail and it creates a sweep according to the section and the rail. You have the same logic in Grasshopper. You have the rail and you have the sections. So say I give it a rail like this, I give it a rail curve like this, and I give it a section like this. I have to create these things manually in Rhino if you want to create a sweep. And then if you input these two things in the rail and the sections, you basically get something like this. It sweeps along the whole thing. It's basically like the follow me tool in SketchUp if you guys use SketchUp, but you have the sweep command over here. So I'll turn both of these things off. Now let's take a look at the plane surface component. It's located right here. If you guys are confused that where are all these components from, where are all of these components located, just press Alt and click on your mouse component and you'll actually find all of these things under surface and under freeform, and it will actually tell you through red arrows and red circles where these components are from. So now let's take a look at plane surface. You basically input a plane and the x and the y size and it creates a surface out of it. So if I would have inputted the xz plane, it would have created a surface on the xz plane. So right now I've inputted the xy plane and given it a size of 55 by 23. We'll create a size, create a rectangle of 55 by 23 like this. You can control the x and the y size of the surface. So if I double click and type xz, and if I bring in the xz plane, if I input it inside plane, you see it creates a surface on the xz plane. So I'll plug this back in and delete this, and I'll place all of these things under disable preview. Now let's go and check out this particular component which says bounding box. Basically takes in a bead up. It takes in any kind of a bead up that you want it to take. A deformed bead up would do just fine. In this case I've input a sphere so that you guys can understand what bounding box does. It basically creates a complete box which encapsulates or encloses any kind of a geometry. So in this case I have a sphere and it asks for the content. The plane is by default XY. As you can see, it actually tells you world XY, and if you turn this on, you'll see that it has created box around your surface or around your bead up. So I can turn this off. Now you have the box rectangle component. The box rectangle component basically is located over here, as you can see under primitive. It takes in XY plane, the X and the Y size, and creates a rectangle first, like this. And the rectangle goes inside this rectangle input. So if you bring the box rectangle component, you see this component is basically just a rectangle. It creates a rectangle on a plane. And the box rectangle component creates a 3D out of that. So you can actually see where this component is located. It's located right here under primitive under your surface tab, and you can input the rectangle in rectangle, and you can actually give it a height of any distance that you want to, and you can control it parametrically like this, and it will create a box for you. So just turn this off. The next component is the center box component. The center box component creates a box or a 3D cuboid from the center of its volume, or from the centroid of its volume. So I have X, Y, and Z dimensions. So it basically creates a center box like this. So if X is 17, it considers the X to be 17 from the center, which means this will be, and this dimension will be 17 divided by 2. So it basically breaks it down like that. So the box is created from the center of its origin, or from the centroid of its volume. And then you have 17 as the X dimension, which is basically this dimension. You have 13 as the Y dimension, which is basically this dimension. And you have 11 as the Z axis dimension, which is basically this dimension. So you can control all of this like this. You have this and this, and you have the height. So as you can see, the box is being created from the center of the origin. So I'll turn this off. Now let's go to this particular component, which is the sphere component. If I use the Alt key over here just to see where it belongs, it belongs in primitive. It's basically like the circle component, but it takes in a XY plane, and it takes in the radius, and it will give you a sphere. So you can control the size of the sphere using the number slider of the radius. Let's move on to the next component, which is isotrim. We have seen the isotrim component in the first tab, which is the math tab. We had actually used it with, I'm guessing, the divide domain square component. So you see you have the divide domain square right here, and the isotrim component was used to create divisions like this. So you can basically attach a surface to the divide domain square, and you can attach the segments to domain and the surface to surface, and get boxes like this, or divisions like this. The next component is offset surface. So I'll turn this off, and I'll turn the offset surface command on. So you basically have a twisted surface like this, and if you want to offset this surface, you want another surface which is offsetted from this surface by a particular distance. You can use the offset surface component, which is located right here. Under the surface tab, you have it under utilities right here, and you can basically input the surface and input the distance, and it will give you its offset, just like a curve. So I'll turn this off for now. So that's it for your surface tab right here. So we have completed the math tab, the set tab, vector tab, curve tab, and surface tab. These 5 tabs, the most important that you should know about in Grasshopper before we proceed with any sort of other algorithms and operations. Now we'll actually be taking a look at the concept called data trees, since we have explored all of these tabs and now we know which is which, and we have an idea about how things work in Grasshopper. Let's understand the very important concept, or a very crucial concept, of data trees, which actually explains how data is exchanged and how data is stored between all of these components in Grasshopper 3D.